In this video, we're going to talk about the discriminant of a quadratic function. So our quadratic function has to be in the form ax squared plus bx plus c equals 0 in order to determine what the discriminant is. So given this form, the discriminant of the quadratic is b squared minus 4ac, and sometimes we use this symbol, which is a capital delta, to talk about the discriminant. The b comes from the linear term, the coefficient of the linear term in the quadratic function. 4 is a constant that will always be in this expression. A is the coefficient of the squared term in the quadratic equation, and c is the constant term in the quadratic equation. What the discriminant will tell us, we can use it to determine the number and nature of our solution. So there's 3 scenarios that our value for delta can be. So case 1 is our delta is greater than 0. So if we calculate this expression, plugging in our b, a, and c, and we evaluate it, if delta is greater than 0, this will imply that we have 2 real solutions. That's case 1. Case 2, if delta is less than 0, this will imply that we have 2 complex solutions. The third case, if delta equals 0, this implies we have 1 real solution. That's really what the discriminant is used for. It's going to tell us what kind of solutions we have. If you remember the quadratic formula, this is the expression inside the square root. This is the radicand. And so again, if it's greater than 0, you can take the square root of a positive number and you get 2 real solutions. If that number is negative, then when you take the square root of it, you'll get 2 complex solutions. And if it's equal to 0, the square root of 0 is 0, and so we'll only get 1 real solution from that. So we have 3 examples to look at, to go through real quick. And again, all we're going to determine is whether or not our discriminant, our delta, is greater than, less than, or equal to 0. So in example 1, our delta will equal negative 3 squared minus 4 times 2 times negative 5. Evaluating that, we should get 9 plus 40, which is 49. This is greater than 0, and so we have 2 real solutions. Example 2, our delta will equal 12 squared minus 4 times 9. Well, 12 squared is 144. I'm going to subtract 4 times 9, which is also 144, which is 0. And since our discriminant is equal to 0, we'll have 1 real solution. Last case, 3x squared plus x plus 4 equals 0. So our delta will equal 1 squared minus 4 times 3 times 4. This is equal to 1 minus 48, which is negative 47. Negative 47 is less than 0, and so we get 2 complex solutions. And that's our video on the discriminant.